So we've just completed our initial measurement import and our config wizard. So if we kind of go back to our little checkbox, we've gone through steps 1 and 2, and we've actually kind of gone through part of step 3 because we named our config baseline when it first came in. Now let's take a quick look and see what what are the actual results of that. We've been looking at this graph here that we named as part of our import. On the left-hand side, if you click on data view, you're going to see that we have some information here now. We have our measurements for our subs. If you double click on one of these, I thought it would actually show you the measurements. Yeah, there we go. Right click and it'll show the imported text. You can actually see what we got brought in. Really nothing to do with these measurements, so I typically just minimize that. And then here we can see our graphs, right? And we'll be creating multiple graphs, and we'll get into renaming graphs and renaming traces so that we understand what we're actually looking at, and it shows up properly in our graph scale down here at the bottom. But the one that's more interesting to me, and this is kind of where the wizard really helps out a ton, is on this config view down here at the bottom. At the top, we see configurations, and notice, remember, we called this config baseline when we imported it. So if we expand baseline, we're going to see a bunch of information out there. If you remember, we have 3 listening positions and we have 4 subs. So if we look down here on our subwoofer channels, we see I'm going to have a channel for each sub. I have a left front, I have a left rear, I have a right front, and I have a right rear. That corresponds to the names of my different subs. When we did the import, when we did the configuration wizard, we also said, hey, I want 5 PEQs per channel. I also want gain and delay blocks. So if we look at each one of these things, we can see under each channel, there's a filters folder. And I can see I've got 5 PEQs, a gain block, and a delay block. And these are the things that we're telling MSO, hey, you have these things to work with when you're trying to get me a good sub response, okay? As far as our listening positions go, those are part of the optimization parameters, and they get put into something called measurement groups. This is where we associate our different measurements, our different sub measurements with each listening position. So what we're looking at on the right-hand side in this particular graph are the results of these measurements that are summed from REW within MSO. What's interesting is if you go into REW and you use the trace arithmetic function and you add all of these together, the charts are going to be exactly the same as what you have here in MSO, right? So that just kind of shows you, how this data gets imported, and then it's the same stuff that we've brought in. All right. So our next step that we want to do is, I personally, again, this is how I use it, is I don't like making any changes to my baseline configuration. I always want to keep, whoops, I double clicked on that. I always want to keep my baseline configuration vanilla. I don't want to change anything on it or tweak anything on it. So I want to create a configuration that we're actually going to use to run an optimization. And that's where we're going to go in and talk about some of these measurements and some of the optimization parameters that we kind of glossed over a few minutes ago. So the cool thing about this, and this is one of the really powerful things about MSO, is it's really, frankly, pretty trivial to duplicate our configurations. So if I right click on baseline, you're going to see down here about the third or fourth one, third section at the very top, there's a clone configuration. So we're going to go ahead and select clone configuration, and it's going to pop up a dialog, and we're going to give this thing a name. Let's call this, I think Andy calls them iteration 1 in his demo. I'm just going to call this optimization. We'll call this optimization 1. I usually use much more descriptive names for my configs. So, I might put something like the target level. So maybe we'll optimize for we'll just use the basic default config. Maybe this is going to be a 75 dB, and we're optimizing from 15 to 160 hertz with 5 PEQs. The reason I like to do this is because as you start getting more and more configurations, it becomes really, really easy to lose track of which configuration is what without having to drill in and look at each configuration option that you have. So this just gives me a little bit of a better idea of what's out there. And we are going to go ahead and clone the associated graphs. So let's go ahead and say, okay, and we'll see that we've got a new configuration out here right below our baseline, and it's called 75 dB is the name that I gave it. And if we expand that, it's going to look exactly like our baseline config, which is what we want. If we go to the bottom left and we click the data view, we can see we've got a new graph as well. We said, hey, go ahead and clone the graphs as well. So if I right click on it, I say show, the first thing I want to do is I want to rename this graph. I want to clean up this name. So let's get rid of the this copy of baseline bit, and we're just going to call this my 75 dB PEQ, 5 PEQ rather, listening position graph. I want to make one more change to this. So I want to right click, I want to go to graph properties, and I want to change this name here because it cloned it for us earlier. So I'm going to call this a 75 dB -15 to 165 PEQ listening position responses. We'll say apply. Now, one of the cool tricks about cloning configs is if I go down to data, the data that we're graphing is those measurement groups that I showed you earlier on the config. When we clone it, it automatically selects the proper measurement groups for this graph. So we don't have to go in and actually change any of this. I'll show you in a minute how to create a custom kind of before and after graph so you can see what things look like, both obviously before and after, but also while the optimization is running. So we'll go ahead and say, okay. Now, if I right click on this and I say, hey, let's go ahead and show my graph. There's my new graph. It's got the new name. It shows the proper name up at the top of the toolbar, and it shows the proper name for the graph title. If we flip back and forth by selecting the proper tab, come on. Oh, there it goes. It actually will, the graph's going to be identical, right? So it's just the title changing because we haven't done anything yet. So the next thing that we want to do is I want to create a graph from scratch that's going to give me a nice before and after view of our optimization before we run it. So if we go on the left-hand side, we select graphs. If we right click on this one, we can see new graph. So we'll go ahead and say, let's create a new graph. Our data, remember, is going to be from measurement groups, okay? We want our baseline positions and we want our optimization positions. So let's just go ahead and we're going to select all of these and we're going to say apply. And we're going to get this graph that pops up here. So that's got our data in it. This is going to be our before, which is our baseline, and our after, which is our 75 dB here that we're doing. Now I want to go ahead and tweak some of this. So I'm going to call this graph before and after. I want to show the legend so that we know what's what. We'll click apply. Let's go make the same axis tweaks that we made earlier. I think I went down to 15 hertz, or maybe I went down to 10 on my graph. I don't remember off the top of my head. My y-axis, we're going to make that the same 40 and 110 that we did earlier. We'll say apply. So now I've got a nicely formatted graph here that we can look at. So when we create graphs, it doesn't by default know really what to name things. So the first thing we're going to do is let's go ahead and change the graph name here on the left-hand side. Right click, rename the graph. We're going to call this before and after. So now that changes our tab name up here at the top so that we can see the proper thing we're looking at. If I expand this, it's going to show me the data that it's actually graphing, but these aren't really descriptive. So what I can do is if I click the plus sign next to one of these, I can see the configuration and the group that's actually being optimized. So now I can easily go in and rename each one of these channels so that it's more descriptive and we know what we're looking at. So if I right click, I can rename it. I'm just going to call this base. I'll call this base left. If I expand the next one, rename it. This is going to be my base MLP. And you can see as we make these changes on the left, it's changing our legend at the bottom of our graph. Expand this one. This should be my little bit of a lag. Sorry. There we go. So if I expand this one, this is going to be my base right. And here we can see the other ones. I'm just going to call this one, I'm going to call this one 5PEQ left. This one should be MLP, and then the bottom one should be right. So we'll call it 5PEQ MLP. And then we'll call this one 5PEQ right. So now everything is named. The problem is that everything is on top of itself. We want to be able to clearly see which, we want to be able to clearly see our optimization as it's running. So what we can do is we can actually offset the optimization graphs that we're going to run. So if I right click on one of these and I go to properties, magnitude display offset in decibels. So here I can say, okay, how far offset do I want this to be from where I'm actually running it? You can pick whatever you want. You just want to get it kind of sufficiently below the graphs that are up there. So it looks like, I think we're going to run this one at 75 dB. So that's going to put it kind of right here kind of in this middle, which is still going to overlap a little bit. So if we're going to optimize at 75 dB, and I want to get it clear, let me just drop this off by another 10 dB. So if I say apply, you'll see it's going to drop it down by 10 dB, and we'll do that for each one of our graphs. Properties, set it to -10. We'll apply, and for our last one, properties, let's set this guy to -10 and apply. Cool. So they're all overlapping quite a bit, but remember we're going to optimize for 75 dB, and the offset is from that optimization. Target. So they're actually going to end up centered somewhere around 65 dB, which is way down here. So there's going to be plenty of room for us to see what our optimization is doing, and have that clear of our baseline response graphs. So we've got a nice before and after chart ready to go. What we now need to do is we need to get into some of the nitty-gritty on our optimization options and actually run the optimization itself.